Okay, let's look at another example of matrix multiplication. So example number 2, let's say we have the opposite way. So this matrix first, 1, 2, 3, negative 1, 0, 1, times 1, negative 2, 3, 1, 0, 2. Do we expect that multiplying the same two matrices in a different order will give us the exact same resulting matrix? Remember, dimensions are very important. So this one is a 2 by 3 matrix. This one is a 3 by 2 matrix, which means that when we multiply these together, the product will be a 2 by 2, not a 3 by 3. So actually, matrix multiplication is not commutative. We can't just switch the order and get the same thing. We get a whole different result. Okay, so let's go ahead and multiply these. See if you can go through the multiplication on your own. Remember, going across and down, across and down. All right, so if you need a pause to do the work, you can. I got this 2 by 2 matrix, negative 5, 7, 1, 4 as the result. So notice multiplying the same two matrices in different orders will not give you the same answer. Also, it may not even exist to do it the other way. So I'm going to leave a little note here. A times B does not equal B times A. And then also, AB might exist, but BA not exist. That is also possible. Okay, so remember that. All right, the next thing I want to talk about is matrix transpose. So sometimes a matrix as is not helpful, but we may need to transpose it for some reason or another. I know when I program things and use matrices, I often have to use the transpose of the matrix that I got from my data. All right, so matrix transpose. All right, so let's say we have a matrix A, and it's an M by N matrix. A transpose is actually an N by M matrix. So the only difference between a matrix and its transpose is that we switch the rows and the columns. All right, so let's look at an example. All right, so let's say we have a matrix A, 1, 0, 2, negative 1. We can think about its transpose. So you're going to take, let's say, the first row, 1, 2. It's going to become the first column of our transpose. The second row, 0, negative 1, will become the second column. So this is A transpose. All right, another example, let's look at matrix B. Down the columns, I got 0, negative 2, 1, 3, negative 3, 2. All right, and then I want B transpose, so instead of this being the first row, it's going to be the first column. All right, and then let's talk about one final thing about transpose matrices. All right, so I'll write it as a little note here. A times B, so if you take the product of A times B first and then transpose that result, that's actually the same as taking B transpose times A transpose. So you can't just distribute out the transpose. It's not going to be the same. And then I will show you. So let's say we have our same two examples, A and B. All right, you can multiply this to check that my answer is correct, but I'm just going to go straight to the answer. If I multiply A times B, my result should be a 2 by 3 matrix. So I got negative 4, 2, 7, negative 3, 1, negative 2. All right, so that is the product A times B. I'm going to take the transpose of that. So this first row will become the first column. All right. Now, I said here that AB transpose this is the same as B transpose A transpose. Let's actually look at that. Let's look at B transpose A transpose. All right, so here's B transpose and A transpose. And so when we multiply these two, we actually get this again. Okay, so this is something to remember. AB transpose is actually B transpose A transpose. All right, so this is the end of the section on matrix multiplication.